Welcome back, everyone. Today we're going deep into a topic that's both familiar and kind of mind-blowing.
Intriguing.
We're talking about sex. Or, more precisely, whether sex is always necessary for survival.
Getting right to the heart of it.
You know, it seems like a basic fact of life, right?
Yeah, you'd think so.
But as we'll see, nature has a knack for bending the rules.
Right, nature loves to keep us guessing.
We've got research on albatrosses.
Albatrosses, huh? Those majestic birds.
Geckos.
Okay, getting smaller.
Rotifers, even sharks.
No, that's a wide range. So what's the common thread here?
They all point to this fascinating world of all female species thriving without males.
Now that's a twist.
And not just surviving, but often incredibly successful.
Challenging the very idea of what we think is essential for life to continue, huh?
Exactly. So, to kick things off, let's dive into a story that might raise a few eyebrows. Lesbian albatrosses.
Lesbian albatrosses. Okay, now you've got my attention.
It sounds like something out of a nature documentary parody, right?
Yeah, almost too good to be true.
But it's a real phenomenon documented by Dr. Lindsay Young, a leading expert on lace and albatrosses.
Lace and albatrosses. Aren't those the ones known for their lifelong monogamy?
The very same. She was studying a colony in Hawaii.
Beautiful place for field work.
And she noticed something peculiar. A significant number of breeding pairs were female-female.
Really? How could she tell? Don't male and female albatrosses look almost identical?
That's what makes this discovery so intriguing. It took meticulous DNA analysis to confirm that these were indeed female-female pairs.
Wow, so they weren't just hanging out, they were actual couples raising chicks.
Not only raising chicks, but sometimes doing it for decades.
Decades? That's incredible. Talk about commitment.
And get this, Dr. Young even observed nests with 2 eggs.
Wait, 2 eggs? But that's impossible for a single female albatross, isn't it?
Exactly. This phenomenon, known as a supernormal clutch, suggests that these females are, well, borrowing sperm from males already paired up.
So they're finding a workaround to ensure they can reproduce, even in a male-scarce environment.
It's like they're saying, hey, gotta do what you gotta do.
That's pretty ingenious when you think about it, adapting to the circumstances.
And it seems to be working, right?
Yeah, and Dr. Young found no difference in the chicks' fledging rates compared to those raised by traditional male-female pairs.
So much for lifelong monogamy being the only way, huh?
It seems like there's always more to the story than we initially assume, especially when it comes to nature.
This brings up a fascinating question, though. Were those females actively choosing to partner up, or was it purely out of necessity?
It's probably a bit of both. You know, the colony Dr. Young was studying was relatively new, with more females arriving before the males.
So they were faced with a choice: wait for a male and risk missing out on breeding altogether.
Or team up with another female and make it work.
It's like, hey, girl, want to raise some chicks together?
And, raising an albatross chick is a huge investment. They need constant care and feeding for months.
Having a reliable partner makes all the difference.
It's all about teamwork and cooperation. And it seems like these lesbian albatross couples have figured out a winning formula.
Now, let's shift gears to another species that's taking female independence to a whole new level. The mourning gecko.
Okay, I'm ready for another twist. What's so special about the mourning gecko?
Well, this little lizard has a reproductive strategy that's truly remarkable. Parthenogenesis.
Parthenogenesis, isn't that like virgin birth?
You got it. The entire global population of mourning geckos is female.
Wait, seriously, no males at all?
Nope. They've essentially eliminated males entirely from their reproductive equation.
That's mind-blowing. So how do they reproduce? Do they bud or split or what?
It's even more extraordinary than that. They essentially clone themselves.
They clone themselves? Come on, that's got to be science fiction.
Nope. Science fact. Instead of needing sperm to fertilize their eggs, these females trigger development on their own. Each egg contains a full set of chromosomes, and the offspring are genetically identical to the mother.
So it's like having hundreds of mini-Mays running around.
Exactly. From an evolutionary standpoint, I can see the advantage. No need to waste time finding a mate.
Just get right to the business of populating the world.
And that's precisely what they've done. Mourning geckos are incredibly successful colonizers found all over the world.
So they're proving that in some circumstances, ditching the need for males can be a winning evolutionary strategy.
But hold on, if cloning is so efficient, why isn't everyone doing it?
Right. Why bother with sex at all?
It seems like there must be a downside.
There is, and it's a big one. Lack of genetic diversity.
That makes sense. If they're all clones, they're all vulnerable to the same diseases, same environmental changes.
It's like putting all your eggs in one basket, genetically speaking.
So sex, with all its messiness and complications,
Oh, the drama.
is ultimately about shuffling the genetic deck.
Creating more adaptable offspring in the long run.
But wait, you said that mourning geckos are a super successful species found all over the globe.
They are.
How have they managed to thrive for so long with this lack of genetic diversity?
That's a great question, and it leads us to our next fascinating example. The lutealoid rotifer, a creature that's mastered the art of, well, stealing genes.
Stealing genes! Okay, now you're really piquing my curiosity.
It's one of the most mind-boggling discoveries in evolutionary biology.
Lay it on me.
These microscopic creatures, all female, haven't had sex in over 80 million years.
80 million years. That's longer than the dinosaurs roamed the Earth.
They reproduce through parthenogenesis, just like our gecko friends.
But how have they survived for so long without mixing up their genes?
Well, they've developed this incredible ability called horizontal gene transfer.
Okay, I'm all ears. What's that all about?
They can incorporate foreign DNA fragments, likely from digested bacteria and fungi, into their own genomes.
So they're like genetic scavengers, picking and choosing upgrades from their environment.
Exactly. It's almost like they've hacked the system of evolution.
So the mourning gecko is a cloning queen, and the butiloid rotifer is a master gene thief, both thriving without males.
It really makes you wonder, is sex on its way out? Is it becoming obsolete?
Well, let's not jump to conclusions just yet. These are just two examples.
Yeah, there's still so much we don't know.
And as we'll see with our next species, the aphid, nature has a way of keeping things interesting, mixing and matching strategies.
Aphids. Those tiny little garden pests. What's so special about them?
They've got a dual strategy, switching between sexual and asexual reproduction depending on the season.
Okay, now that's clever. So they can clone themselves when conditions are good.
Exactly. Rapid expansion in good times.
And switch to sexual reproduction when things get tough, boosting genetic diversity when they need it most.
It's like they've cracked the code for reproductive success, hedging their bets.
Nature at its finest.
What other wonders await us in the world of all female species?
Well, next up, we'll be exploring the intriguing world of the whiptail lizard.
The whiptail lizard.
Yeah, a species where females engage in what we call pseudocopulations, despite lacking males.
Pseudocopulations? That sounds a little, well, intimate for an all-female species.
It's all about triggering the hormonal changes needed for egg production. They've evolved this fascinating way to stimulate ovulation without the need for actual mating.
Okay, now I'm really curious. Tell me more about these gender-bending lizards.
The whiptail lizard, it's another fantastic example of nature's flexibility.
You mentioned these pseudocopulations earlier.
Right.
I'm still wrapping my head around that.
Yeah, it seems a little counterintuitive, doesn't it?
It does. Why go through the motions if there's no actual mating happening?
Well, for the whiptail lizard, these pseudocopulations, it's all about survival.
Okay, I'm listening.
In many lizard species, mating triggers hormonal shifts.
Right, hormones control everything.
Exactly, and these hormonal changes are essential for egg production.
So even though there are no males, these whiptails have found a way to, like, kickstart that process on their own.
Precisely. They've developed this system where they take turns playing the male role.
Take turns. How does that work?
Researchers observed that when two females are housed together, they switch back and forth between male-like and female-like behavior during each reproductive cycle.
Wait, so one lizard will act like the male, and then they switch?
Exactly. It's like a built-in system to ensure they can reproduce without needing males at all.
Incredible. Do they, like, flip a coin to decide who's the male?
It seems to be linked to their hormone levels.
Ah, hormones again.
One lizard will have this surge in progesterone after ovulating, and that triggers her to take on those male-like behaviors, mounting the other female, engaging in courtship displays.
Fascinating. It's like nature found a way to bypass the whole male-female thing altogether.
In a way, yes. And studies have actually shown that whiptails that don't engage in these mock matings lay fewer eggs.
So it's not just for show, it's essential for their reproductive success.
It is. But this brings us back to that recurring question.
Genetic diversity.
Exactly.
Yes.
If all these whiptails are essentially clones of each other.
Vulnerable to disease, right?
Precisely. It's a major concern, but remember, they're still around.
They've been doing this for a while, haven't they?
Exactly. Which suggests they found ways to, well, mitigate that risk.
Maybe they have more genetic variation than we realize.
That's possible. Or they've developed other adaptations that help them deal with environmental challenges. We need more research to fully understand how they've managed to thrive for so long.
It does make you wonder, though, if there are advantages to this all-female setup.
Oh, absolutely. Think about all the energy and resources that go into finding and competing for mates in a typical sexual system.
It's a whole lot of drama.
It is. And some studies suggest that all-female whiptail societies are less aggressive.
Less fighting over mates, less competition.
And they tend to be more cooperative than their sexual counterparts.
Interesting.
Perhaps these all-female communities represent a different way of being, one that prioritizes cooperation over competition.
Okay, now that is a radical idea, but I kind of like it. Maybe we humans have something to learn from them. Speaking of challenging assumptions, let's move on to another discovery that shook things up, this time in the insect world. All-female termite societies.
Ah, yes. Dr. Toshihisa Yashiro's groundbreaking work.
This was back in 2018, right? He discovered these all-female termite colonies in Japan.
The first time this phenomenon had ever been observed in termites.
Termites, those little creatures that can cause so much damage.
They have a reputation.
And they have all-female societies. I thought they were all about kings and queens, strict social hierarchies.
That's the classic model. Males were always considered essential.
For reproduction.
For maintaining the colony, for everything, really.
But Dr. Yashiro's discovery turned that on its head.
Completely. He found these colonies with no males.
No males at all. How are these termites even functioning as a society?
Well, they had multiple queens instead of just one.
Sharing the workload.
And interestingly, fewer soldiers.
Fewer soldiers, huh? Maybe they just don't need as much defense.
It suggests they might be even more efficient than the mixed-sex colonies.
So not only are they surviving without males, they're potentially thriving.
It seems that way. But the big question is, how are they reproducing?
Right. Don't termites need males for that?
In the traditional sense, yes.
What's going on here?
It appears these all-female colonies have evolved a way to bypass that need. Dr. Yashiro believes they're reproducing through parthenogenesis.
Parthenogenesis, like the geckos, cloning themselves.
Exactly. It's quite remarkable.
Right.
But how did they make that leap from sexual reproduction to cloning? It's a huge evolutionary shift.
It is. What triggered that change?
Well, Dr. Yashiro's research revealed that female termites have this amazing ability to, well, close the sperm gate.
Close the sperm gate? What does that even mean?
They can seal off the sperm storage organs in their abdomens.
So males can't fertilize their eggs.
Essentially, they're forcing themselves to reproduce asexually.
Wow, that's some serious adaptation. So, we've got lesbian albatrosses, cloning geckos, gene-stealing rotifers, gender-bending lizards, and now feminist termites. Makes you wonder, is the future female?
That's a provocative question. But before we crown the queens of the future, let's remember that these are just a handful of examples.
Right, we can't generalize from a few cases.
Exactly. There's still so much we don't know about the long-term implications of these all-female societies.
But it does raise a bigger question. What does the rise of these all-female species tell us about the future of sex itself?
A question for the ages.
Is it possible that as our planet faces more environmental challenges, parthenogenesis could become a more common survival strategy? It's a real possibility, isn't it? When you think about all the pressures species face today, habitat loss, climate change, those dwindling populations.
Parthenogenesis, it offers a way for females to guarantee the survival of their lineage, even when males are hard to come by.
Or when the environment's throwing everything it's got at them.
It's like an insurance policy, a way to hit reset when things get really tough.
An evolutionary reset button.
And we're seeing this emergency cloning in more species than you might think.
Oh, like who?
Remember we talked about the sawfish earlier, that one with the incredible saw-like snout?
Yeah, the critically endangered one.
Researchers discovered that some females out in the wild, they're resorting to parthenogenesis.
Really? They're cloning themselves. Why would they do that?
It's a way to bolster their numbers when their population is dwindling.
Wow, that's incredible.
It is. It really highlights the lengths that nature will go to for survival.
It makes you realize how delicate the balance of life is.
It does. But the fact that they can switch to parthenogenesis at all, it's a glimmer of hope.
A sign that there's still a fighting chance.
Exactly. It shows how adaptable life truly is.
Nature always finds a way, doesn't it?
It does. And that's what makes studying these all-female species so captivating.
They make us rethink everything we thought we knew.
About sex, evolution, even the very definition of life itself.
It's like a whole new chapter unfolding, and the females are leading the way.
Showing us that there are many paths to success, many ways to thrive.
So where do we go from here? What does this mean for the future?
Well, that's the million-dollar question, isn't it?
It is. Will we see more species shifting to parthenogenesis as environmental pressures mount?
It's certainly possible.
Could it even become the dominant form of reproduction someday?
That's a question evolutionary biologists are grappling with right now.
It's mind-boggling to think about a world where sex isn't the primary way life continues.
It would change everything.
It would. But one thing's for sure, these all-female species hold valuable clues.
Clues about the adaptability of life, about new evolutionary possibilities.
And it underscores how crucial conservation efforts are.
Absolutely. We need to protect biodiversity, give species the space and resources they need to adapt, whether they choose to do it sexually or asexually.
So what have we learned from our deep dive today?
We've learned that the rise of all-female societies, it's not just a scientific curiosity,
It's a reflection of the challenges our planet faces.
and a testament to the resilience of life in the face of those challenges.
We've seen how females are rewriting the rules, challenging our assumptions about the role of sex.
And highlighting the incredible diversity of life on Earth.
It's a story that's still being written, full of twists and turns.
And one that reminds us to never underestimate nature's ability to surprise us.
To our listeners, keep exploring these incredible creatures, keep asking questions, and keep an open mind. Who knows what other wonders are out there?